Hello everyone, welcome back to our course of the chemistry. Today we continue the lecture Matter and Measurement. We're going to talk about the separation of the mixture. Basically, we have the three methods to separate a mixture. The first one is the filtration. The filtration method is a technique to separate the solid substance from the liquid and the solutions. We have the two methods that are gravimetric filtration, and the second one, as indicated in the picture, that is the vacuum filtration. Due to the faster speed of the vacuum filtration, it is preferred to use to filter all of the. It is preferred to use in terms of the solids mixed with the liquid substances, because it's gonna faster and it's gonna save time of the chemist. And while the gravimetric method is to preserve the fine particles, because it's pretty slow in terms of the speed. Therefore, it is rarely to use in the modern chemistry today. But it's pretty handy to use when it is necessary to do so. Next, we have the distillation. Using the difference in the boiling point of the substances to separate the components from the mixture. This is usually used for the liquid. Okay, we have a basic distillate system as indicated in the picture. Distillate system. This system is widely used in organic chemistry. You're going to determine the identity of the organic substances that you target for. Therefore, this is pretty typical model of the distillation. As we can see in the picture, we have the hot plate in the bottom. Hot plate in the bottom, okay? And then we have the round bottom flask. Round bottom flask containing all of the liquids and the mixture. When it is heated on a hot plate, the liquid could evaporate, and then it could be cooled down inside the condenser by the cold water it coming in, and then is the cold water it touch outside of the condenser, and it's good cool down the gas state inside the condenser, and then the cold water is going out through this way, and then this process is gonna repeat itself. Finally, we collect the final result here in a small beaker or a graduated cylinder. At a specific temperature measured by the thermometer, we could collect the specific liquid substance, and then we use the chromatography to identify the purity of them. We have the last method here. This is pretty handy to use. That is the chromatography. We have the pretty handy method that is used widely also. That is chromatography. Okay, it's based on a difference in the solubility. We have the very common in the organic chemistry as well, used to identifying the substances, the liquid organic substances. Okay, that is the thin layer chromatography in the abbreviation of the TLC. As I mentioned above, is to identify the components of the mixture. Here we have the model of the TLC. We have a thin layer paper, and then it's gonna immerse in the solvent. Okay, the solvent would travel up to the solvent front. Each point of existed on the paper could indicate the identity of the compound, and is show each and separate substances. Hence, we calculate the RF value from it to determine the purity of the compound. Okay? You don't need to care about the TLC for this stage, because in the organic chemistry later on, you could be introduced and dig deeper into this method. The seven is the units of measurement. This is pretty important. That is the main focus of this video. Okay, we talk about the unit in chemistry that we use is usually is the mole. We usually have the abbreviation of MOL. What is the mole? The mole is the number of molecules. 1 mole is equal to 6 times 10 to the power 23 of the molecules. The chemist is lazy. They are really lazy. They don't want to tell, for example, one mole of carbon dioxide, okay? Instead of saying 6 times 10 to the power of 23 carbon dioxide molecule, we just say 1 mole of carbon dioxide. It's much shorter. Hence, it is the most common unit in the chemistry. Mass. We are measured usually in gram and kilogram. One of the specials here is that mass is totally different from the weight, because the mass is usually in kilogram and gram, while the weight whose unit is Newton. Okay, for example, we take 100 kilogram of meat. 100 kilogram is the mass, but to converting into the weight, you're gonna take the 100 kilogram times the g, usually 10 meter per second square, is gonna equal to 1000 Newton. The unit is the Newton, which is way far different from the mass, whose unit are kilogram and gram. One of the things you have to remember, that is all of the measurements have to accompany by the unit. And the unit used widely in chemistry, that is the SI unit, which is the French language system international d'unité. Okay, you don't need to remember the French name, but you just know that is the SI units. We have the example here, we're gonna express the 15469 gram in terms of kilogram. Gram and kilogram are SI unit. Okay, so 15469 gram is gonna be 15.469 kilogram. Other than that, we have the unit of time. That are the seconds, minute, hours. About the volume, we have the unit of milliliter. Liter. Here, 1 cubic decimeter is equal to 1 liter is equal to 1,000 milliliter. 1 cubic decimeter is also equal to 1,000 cubic centimeter and equal to 1,000 milliliter. For example, we have one graduated cylinder. We have the unit of times and the volume, okay, above. We come to the example. We have one graduated cylinder has the volume of 25.00 milliliter, and we express 25.00 milliliter in liter and centimeter. Okay, we're gonna do the simple calculation here. 25.00 milliliter times 1,000 milliliter at the bottom and 1 liter on the top of it is going to be equal to 0.025. Why do we add couples more zero here that are called significant figures is covered in the upcoming video. We have the 4 significant figure, 4 suffix, and as a result we're going to have 4 suffix that are 2500. And why is that? It's going to be in the upcoming video as well. We talk about the 8, that is the temperature. We talk about the definition of it. The definition of a temperature is a measure of the hotness and coldness of an object. The temperature is the physical property. The unit of the temperature are Celsius, Fahrenheit, and Kelvin. Why they come up with the Celsius? It's actually based on the property of the water. At 0 degrees Celsius, we have the freezing water, while in 100 degrees Celsius, we have the boiling water. Hence, they come up with the degrees Celsius based on the property of the water. The Fahrenheit here is the US unit, because most of the American people, they use unit that is the Fahrenheit to measure the temperature. However, it is non-scientific use, okay? So in the scientific field, specifically in chemical field, it is not used to calculate for anything. We're going to use the Celsius and the Kelvin, Celsius and a Kelvin, to measure the temperature in the chemicals. We talk about the Kelvin. The Kelvin is actually the SI unit. Okay, at 0 Kelvin, all of the thermal motion stops. That's why the scientists call it the absolute zero. We have the formula conversion between those 3 unit formula conversion. The degree Celsius is equal to 5/9 multiplied by the Fahrenheit minus 32. The Fahrenheit degree is equal to 9/5 multiplied by degree Celsius and then plus 32. And the Kelvin is equal to degree Celsius plus 273.15. We come to the first exercises. Okay, which degree we're going to use in this case? That is the Celsius, right? So we have the Celsius. When you convert it from the Fahrenheit degree, we have the formula. The Celsius degree is equal to 5/9 multiply Fahrenheit minus 32. We plug the number in. 5/9, 72 minus 32, and we're gonna have the 22 degrees Celsius. We have 2 sig figs in the example, 2 sig figs, and the final result is 2 sig figs as well. You just need to remember one thing. When you calculate anything, the sig figs from the beginning of the given question should be uniform with your result. And about the significant figures, we could be covered in a third lecture, so you don't need to worry a lot for the accuracy of it right now. You just know how to convert between those degree Celsius, degree Fahrenheit, and the Kelvin. In this lecture is the key thing. Okay, continue. We go to the second example. We come to the second example. We convert to 33 degrees Celsius to the Kelvin. We have the Kelvin here is equal to degrees Celsius plus 273.15. The Kelvin is equal to 233 plus 273.15. Is equal to K is equal to 506. We have the unit at the bottom, at the end. That is the K. Okay, it's pretty much simple. We talk about the last one is the density. What is the definition of it? When we talk about the density, you know, how do you know the definition? We look at the formula first. Okay, the formula is D is a density is equal to mass over the volume. Mass over the volume. That means the definition is based on that as well. It is defined as the D amount of mass over a unit volume of a substance. The common units of the density are the gram over cube centimeter or gram over milliliter. The density of the water is very special at 4 degrees Celsius, just only 4 degrees Celsius, okay? Exact 4 degrees Celsius. We have the density of the water is equal to 1.00 gram per milliliter. If it is 5 or 6 or what else, 100 degrees Celsius, it is not gonna be equal to the 1.00 gram per liter. The next example is if an object has a mass of 325.4 gram and take up a volume of 0.125 liter, what the density of this object in gram per cube centimeter? Okay, we're gonna do this right here. What is the formula of the density? The formula is density is equal mass over the volume. And then we just plug the number in. 325.4. We have to include the unit here. That is gram over the volume, 0.125 liter. But we have to convert into the gram per cube centimeter, right? So we have 1 liter is equal to 1000 cube centimeter as we talked above. Hence, we have the density is equal to 2.60 gram per centimeter. Okay. Next, that is the second example. You want to calculate the volume reading of the water level when it rises. You add something into the water. For example, here's water is 60 milliliter, right? When you add an ion in, it's gonna increase to, for example, 80 or 90 or something, right? And this number is the unknown. We're gonna find the water that rise to this level. How do we know? How do we calculate? We base on the density formula. Okay, we have to get the density of that metals. In this case, that is the iron. We have density of the iron is 7.87 gram per cube centimeter. If 83.6 gram is added to 60.0 milliliter of the water in a graduated cylinder, we're gonna find out the volume reading. Okay, so the question, it gives you the D is equal to 7.87 gram per centimeter. It also gives you the mass of the iron is 83.6 gram. What you're gonna have here, you're gonna find down the volume of the iron. Okay, applying the formula, D is equal to mass over volume. We get the volume here is 83.6 gram. We have to write the unit, is really important. Then you divide it by 7.87 gram per cube centimeter. We're gonna come up with 10.6 milliliter at the end. We have the volume of the water is 60.0 milliliter, and we have the volume of the iron as well, that is 10.6 milliliter. Therefore, the volume of the total of water in the graduated graduated cylinder is equal to the sum of the iron and the water that are 60.0 milliliter plus 10.6 milliliter, and we have 70.6 milliliter. We could say the water will rise up to the level of 70.6 milliliter after adding the iron. Okay, we finished the first lesson here, so we will come back in the next lecture.